This episode of Fluid Power Forum is sponsored by IFPE Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFPE spans the 13 central states from Minnesota to Texas. For more information, visit ifpeusa.com.
We think this control architecture can reduce hydraulic hysteresis to almost zero, reduce response time, improve repeatability in the valve performance, and reduce variability in performance from valve to valve.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, as always, we ask you to follow us on Twitter. That's where we put a lot of podcast announcements. You can find us on Twitter at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on almost all of the other podcatching services that are out there. Wherever you find us, subscribe and then give us a quick rating. Those ratings really do help promote the show and let more and more of our friends in the industry join in on these important conversations. On today's show, our guest is Russ Schneiderwind. Russ is the Director of Business Development at Hydroforce. And Hydroforce is a company that designs, manufactures, and markets hydraulic cartridge valves, custom manifolds, and electro-hydraulic controls for use in both industrial and mobile equipment applications. We invited Russ into our forum today to learn more about a new digital proportional control product that they're launching, as well as some of the other items that you will see at the Hydroforce booth at the upcoming IFPE trade show, the International Fluid Power Exposition. So Russ, welcome to Fluid Power Forum.
Thank you, Eric. Glad to be here.
We're glad to have you on the show today. Tell our listeners a little bit more about yourself and your background. How'd you come up through the ranks, if you will? How'd you find yourself at Hydroforce?
Yeah, so I went to university at Iowa State University, and I started my career in hydraulics at a company that used to be called Sauer Sundstrand. Mm-hmm. Now it's called Danfoss Fluid Power.
Right.
And they're located there in Ames, Iowa, where Iowa State is as well. And I interned there and then started working there as an application engineer. And I got a lot of experience, learning about pumps and motors and hydrostatic transmissions, but wanted to expand my knowledge into valves. And at that time, Sauer Sundstrand really didn't have a very complete valve line, right, and was kind of exploring other alternatives. And I was kind of fascinated by the cartridge valve technology because if those people who have had the pleasure of applying hydraulic cartridge valves understand that it can be a very unique career in that there's these puzzle pieces you get
right
to put together to create unique solutions for customers. And so looking in that industry, I found Hydroforce at the time at a young age and was able to join Hydroforce in 1996. And now I've been there for more than 25 years and have had the pleasure to enjoy very many different roles within the organization.
I'm going to guess that even after 25 years, you've yet to encounter every configuration and every application for cartridge valves, right? There's just so many of them.
Yeah, absolutely impossible. Yeah, absolutely impossible.
I don't know if that's in the Guinness Book of World Records or not, but they're, as you said, they're almost infinitely variable, and it's an exciting product to be associated with, I'm sure. So, well, tell us a little bit more about Hydroforce then as a company. You've been there for a long time, so I think it's a brand that a lot of people are familiar with, but tell our listeners more about Hydroforce.
Sure. We focused on cartridge valve technologies we just discussed, mm-hmm, and we primarily focused on electric over hydraulic cartridge valve technology. Mm-hmm. So a lot of our product development was in anything that has a coil on top of it. And yeah, you mentioned already, we focused a lot on customized manifold system technology. And then, of course, we've added electronics to our product line. Mm-hmm. We've always tended to focus mostly on mobile equipment, so anything in harsh outdoor environments. So we've designed our products to withstand that type of environment, high vibration, water, rain, cold, various temperatures, hot. We typically say that if it claws, digs, spins, or lifts, we want to control the speed and force of the motion on those vehicles. So you can guess our primary markets are construction, agricultural, material handling, municipal, and specialty vehicles, stuff like that.
Yeah, that's great. And you have a worldwide footprint, don't you? Do you manufacture all over the world, or is that all U.S. based and delivered to the world?
Well, our headquarters are in the U.S., but yeah, we have manufacturing sites in the U.K., in Changzhou, China, and also in Sao Paulo, Brazil.
Wow, yeah. So you're covering the three hemispheres, if you will. So
right. Yeah.
The Americas, Europe, and Asia, exactly. So,
yeah.
Well, that's great. So I said at the beginning that we were going to talk about a new digital proportional control product that you guys are putting out, but maybe before we go there, we can talk a little bit about the why. Why is there this demand for digital proportional control in the marketplace? What are you guys seeing and responding to in developing that new product?
Sure. One of the pleasures I've had to work as a director of business development now is to look at mega trends, and some of the trends we're seeing on the horizon that will drive major changes in the hydraulics control industry are moves to alternative power sources, in response to government mandates and these regulations that will require hydraulic systems to become more integrated with electronic controls and sensors to improve the overall performance and productivity of the hydraulic system. So one way we see to improve the overall machine productivity and also potentially energy efficiency, is through the development and application of autonomous assist functions for repetitive motion. Things like what some people might be familiar with, like return to dig, return to height, auto leveling, autonomous steering, or auto grading, as just a few examples where automated assistance control systems could operate more precisely with less correction than a manual operator. Yeah, so in order for these autonomous functions to, work efficiently and consistently from machine to machine, we're going to need an electrohydraulic system that is repeatable. And using today's current hydraulic components and controllers, typically requires intensive tuning and/or field adjustment to accomplish that. In addition, hydraulic control systems will be required to provide more information or data about the performance of the system through telematics to the operators or even the owners of the mobile equipment. So I think many of us have seen today that a lot of companies are working on solutions for the communication and storage of this data, but we think the means through which to gather this data may not yet be available in the market for off-highway equipment. There certainly are servo control valves that are currently, offered in do this sort of thing for data and industrial applications, but these products may not be able to meet the cost or durability requirements and the harsh environments where mobile machines work every day.
Yeah, it's interesting. I appreciate that review, if you will, of a lot of trends that are kind of coming together in one place, if you will, in the mobile equipment industry. And it really is that autonomous or semi-autonomous functionality is not just because there aren't enough skilled operators, which there aren't, but also for productivity, I'm assuming, right? So it's really more of a data management. Increasingly, it's a data management issue than it is a hardware issue, right?
Yes, that's correct. Yeah, and being able to operate more precisely and more accurately, right? That's where we get the productivity gains.
Right. And so that obviously is one of the primary assists or functions of digital controls, right? Electronic controls and proportional control. So Tell us a little bit more about how you see that happening or how you see that working in some of those applications.
Sure. As we started off, we talked about how Hydroforce has been really focused on the electric over hydraulic technology for hydraulics. And we think digital proportional control technology is the next step.
Mm-hmm.
And we see it as the optimal integration of electronics and sensors and our traditional hydraulic proportional valve technology with a software interface that's easy to use and can easily interface with the overall machine electronic control system. So we think this control architecture can reduce hydraulic hysteresis to almost zero, reduce response time, improve repeatability in the valve performance, and reduce variability in performance from valve to valve. This reduced variability in performance from valve to valve can reduce or even eliminate the time required to calibrate the control valves as they are assembled onto the machine in the factory or in the field during service and repair.
Wow.
Yeah. And in addition, digital control devices can provide data and insight on the performance of the proportional digital control to the overall system and telematics monitoring service, just like we were talking about, before.
Right.
With this in mind, digital controls can be used to precisely control the speed or force of work functions, the displacement of pumps and motors, and they can even be, used to create some, creative electrohydraulic systems using something like electronic load sensing or electronic compensation.
Yeah, there's a lot of new capabilities that come online when you have this kind of technology available, it sounds like.
Absolutely.
And so the new product that you guys are launching, I want to hear more about that and the different pieces. If I understand it right, it's got several embedded pieces of technology, one of which is a sensor. So tell us a little bit more about how the product actually works.
Yeah, sure. The sensor that we integrated is an LVDT, which is a linear variable differential transformer.
Mm-hmm.
And that's nothing really new, I would say, in the fact that it's used a lot in, say, industrial or laboratory environments. But we custom designed that product to fit on the cartridge valve and work with our product in particular. And when we developed it, it can give very good spool position accuracy because we link the LVDT to the spool. It can give accuracy to within 0.11 millimeters. Included in this LVDT package that we made for the cartridge valves we designed for the cartridge valves, there's a driver circuit which it powers a primary winding with a constant amplitude AC supply. Then the movement of the sensing core that's linked to the spool in the hydraulic part of the proportional valve induces a voltage into secondary coils.
Okay.
That is proportional to the position of the sensing core within the transformer. So that driver circuit then processes, rectifies, and filters the secondary current to provide a 0 to 5 volt output, and this forms the feedback leg of the PID loop that we use to get to understand the position of the spool.
And Russ,
go ahead.
Yeah, it occurs to me that maybe we should talk just a little bit about the internal structure of cartridge valves.
Oh, sure.
The spool that you're referring to, and I'm out on my skinny branches here in terms of my understanding of the technology. I mean, that's the thing that actually controls the amount of fluid that's going to flow through the valve, and then gives you different amounts of flow and output to the different actuators. Is that right?
Yes, that's correct.
Okay.
So depending on the type of cartridge valve, we control the flow or direction of oil to the actuator or motor using the spool and the cage. And that's the specialty of cartridge valves. And where we position that spool in relationship to passages in the cage will either dictate the direction of the flow or the amount of flow that's going to the actuators. And so, when you have a digital control like we're talking about that can precisely position that opening,
mm-hmm.
then you can precisely position, or you can precisely control the flow and or direction of the flow.
Yeah, so back in the old days, that spool could always be open or closed, right? So it would either allow flow or not allow flow, and that's kind of the grandfather's. That's our grandfather's cartridge valve technology, right? So,
Yes.
but now you're talking about using digital and electronic control to precisely, and you said within fractions of a millimeter, position that spool so that it can very finely control the amount of fluid that's getting through. Correct?
Yeah, that's correct.
Okay.
So when you are able to understand where the spool position is, then you have to do something with that. And so we had to create a new driver controller that we call an ESDR.
Right. Okay.
And what happens then is that 0 to 5 volt output goes to this ESDR. And the ESDR is a controller. It's a specifically designed PID controller that has a CAN interface, 2 PWM outputs, and that one analog voltage input where we're getting the signal from the LVDT.
Mm-hmm.
So we take that LVDT signal with 0 to 5 volt proportional output, and we adjust the current then through those PWM outputs to the coils on the proportional valve. And the goal of the PID loop then is to match the exact set point that is sent to the ESDR through a CAN message in the overall machine control system.
Right. Yeah.
And then that ESDR can do more than just that. It can also even transmit diagnostic messaging back through the CAN network. And so it's got some other powerful capabilities as well.
Yeah. Listeners to our show have known that I often ask for more details on how the electronics part of these products work, and that was an excellent example, Russ, to show that it's really the flow of these electrons that is really making a lot of control things happen inside the product and then on the machine, right? We'll continue with our guest in just a moment, but first let me tell you more about IFPE, the International Fluid Power Exposition. IFPE is the place where you can learn everything you need to help your company stay at the forefront of the megatrends affecting your business and industry. From sensor technology and data analytics to robotics and automation, you will see the latest innovations in fluid power that will help your machines and applications achieve your technology, performance, and business goals. Only at IFPE can you have those in-depth technical conversations with other engineers and other executives to spark new ideas. Or talk with suppliers about your specific challenges and the solutions they can offer. Or find new suppliers and new ways of doing things. Or attend innovative education classes and sessions covering the latest fluid power topics and industry trends, including some taught at the college level and providing professional development hours. No other trade show brings together as many sectors of the fluid power, power transmission, and motion control industries together in one place. And this event happens only once every 3 years, in conjunction with ConExpo ConAg, the largest international gathering place for the construction industries. Our next show is going to be March 14 through 18, 2023 in Las Vegas, Nevada. To learn more or to plan for future shows, visit IFPE.com.
Yeah, and that's the key to our thoughts about the key to digital proportional control, right? Being able to, optimize the performance of a hydraulic valve based on, the not only the electrical components within that and the sensors, but also the software. There's a graphic user interface we've built into this ESDR that uses our HF Impulse configuration and programming software that we offer for free. And what that allows users of our digital proportional valves to do is tune the PID loop as they want. We optimally will tune the PID loop in production so that it fits most applications. Mm-hmm. But the operators or users of the actual device in the field can control a lot more parameters that we make available through that graphic user interface.
Yeah. So as you said, I mean, that LVDT sensor, if that's what you called it,
yes.
and the supporting architecture that you just described I mean, the results are, quicker response times and better repeatability and other kinds of performance characteristics that are improved as a result. Do you have any kind of data on what those improvements actually are, or can they be measured? Like how much more effective is this product in some of those areas?
Yeah, absolutely. Since that PID loop controls the spool position very precisely, and we're not just simply controlling the coil current like we normally would do, in other closed loop control schemes, we're able to virtually eliminate hysteresis. We've seen reductions from, around 3 to 5% to around 1% of hysteresis with the digital proportional control. Also, since we can set up the controller and PID loop in our factory, we can optimize the PID control by allowing the loop to overdrive current to push the valve to a position faster, right? And so we've seen anywhere between 45 to 75% improvement in step response when compared with an open loop control of the same valve. So we take the same valve with using the sensor and not using the sensor, and we compare them, and we see this this improvement in step response. Also, since we set that LVDT based on a flow output in the factory, we can almost guarantee that at every given command, it'll always yield the same flow. Because like we were talking about that opening, it's positioning that spool in relation to the cage to create that very same opening every time. Right. And then if we do that for every single valve as it's going down the factory line, it results in very good repeatability from valve to valve. So far in the valves that we've produced, we see in multiple lots performance within 4% of each other.
Oh, that's amazing. I wonder if you can help us. So it sounds like a significant advance, first of all, in terms of the ability to control movement on a lot of these applications. But I wonder if you can give us some specificity about, are there particular applications that this is really suited for, that would really get the most benefit out of this technology? And what would those be?
Sure. We designed this product to go into our biggest, markets and applications that we already kind of discussed: the ag, the earth moving, grading, municipal vehicles, specialty vehicles, right? But where it's going to shine is anywhere where either a customer today is struggling to achieve precision or accuracy of a position of an application, of whether it's product being applied, say like on a sprayer, or movement of product like lifting and positioning, right? So, and as these OEMs demand more precision and of course also faster response, we think they're going to find it difficult. We know some of our customers find it difficult to accomplish this with traditional proportional valve technology. As an example, when we do apply our traditional proportional valve in an environment where they need very precise or fast response, they have to do a ton of tuning in the factory floor, which takes a lot of time, right? And so, we do know there are industrial products that are out there, but like I think I said before, we just don't think they're fit to be applied in the harsh environment of mobile equipment.
Yeah, we're seeing that in a lot of technology spaces right now, where what has been, true in the industrial setting is trying to be mapped onto the mobile setting, and it's not the same thing. You don't normally, the factory's not 30 degrees below zero, for one example, right? So sometimes the mobile environment is. So
you hope not.
You hope not. Exactly. I don't want to work in that factory, that's for sure. So
that's right.
So another idea, something else that occurs to me, energy efficiency, is becoming more and more of a driver, and the need to save or use less energy. How does that, is that something that this product helps with as well, either in the recovery or just the saving of energy?
Yeah, we think that obviously there's several ways to reduce energy consumption, and as we've been talking about, we think automation or autonomous assist functions, can help to reduce energy consumption. So the theory being that if you can eliminate the corrections being made by an operator that's controlling the function manually, you can improve the overall efficiency and use of the power source. We obviously, you even just mentioned, we see a reduction in experienced operators, and we see the introduction with more inexperienced operators or even fewer operators out there in the industry, right? But the potential improvements in energy efficiency will only become greater through the use of these autonomous assistant functions, we think.
Right.
We can also create energy recovery systems, like you mentioned, and we think that they are optimized if you have this autonomous or more precise control of the pressure and flow in the electrohydraulic system. Yeah. And, energy recovery improvements in overall efficiency will continue to be very important in the future, right? Especially as equipment moves away from the traditional diesel engine as a main power source. So far, we know, or we're seeing that the alternative energy sources, are going to require a step increase in efficiency to match that the power density of today's typical diesel engine.
Right. Well, Russ, it sounds like this technology is responding to and addressing a lot of the trends and challenges that are in the markets that you're focused on. How would you summarize that? What's the biggest impact that you think? What biggest challenge are you solving in the market with this product?
Well, one thing, we mentioned before, this sort of thing can be accomplished. These sorts of control can be accomplished, using the similar technology that we have today. But we think that, as that PID loop control, from the vehicle controllers that are on the machines, has to try to control all these functions across the wide spectrum on those machines, it's really going to require the main controller to become much faster, higher cost, with higher I/O, right? So our thought process is a little different. It's sort of this comes from a cartridge valve background, to be honest. We think that these digital proportional controls can address some of the barriers to adoption by creating unique distributed control strategy that uses what we like to call simple plug-and-play CAN networked coil-mounted drivers that can be easily added to individual functions as needed. This way, that main vehicle controller only has to manage the requested valve opening, like we mentioned earlier, through a CAN signal, and does not have to perform all the high-speed, corrections or attempt to manage the hysteresis of our valve in that particular function. And this modular architecture also gives vehicle designers flexibility to develop these solutions that fit, within their, tightening cost and performance parameters.
Yeah, it's very adaptable. It sounds that way in terms of, being able to do just what it needs to do in just the right space at just the right time, right?
Right.
Yeah.
Yep, exactly. You don't have to do it all at once. You can integrate it as you need it.
That's great. A lot of people, as these trends manifest themselves in these markets, one painful question that often gets asked is do we still have to use hydraulics for all this stuff? Isn't there some other technology that we could use? That's a painful question for me, obviously, to hear people ask that. But let me ask you, Russ, why? Let me phrase it this way: why is hydraulics still the best technology for some of these applications that you're looking at?
Yeah, I think that's a big challenge, especially with some of the changes in power source that we mentioned above.
Yeah.
But we think, regardless the power source for the vehicle, that the compact power of hydraulics is still the most competitive from a cost and performance standpoint for motion control of high force applications specifically. In the case of digital proportional control, the hydraulics, they're really continuing to do much of the same thing as we've done before, but now we're offering a product that can do it much more accurate and precisely and in a more repeatable fashion that should compete well with the disruptive technologies, if you will, that are entering the market space.
Yeah, that's great. What can people? First of all, why is IFPE such a great show, and what can people expect to see at the Hydroforce booth there?
Well, I think I've gone to IFPE for many, many years now, and I think what's great about it is that it's such a concentrated, I guess, demonstration or opportunity for people to see, what's going on in our industry.
Yeah.
And so I think that's what makes it so great. And there's a lot of camaraderie there, and it's great to see everyone who in the industry and get to see what all these other companies are promoting and developing.
Yeah.
For Hydroforce, we're going to be promoting this digital proportional control as we just discussed, but we're also going to be launching our new version of HF Impulse 2.0. And a new proportional load holding and safety device, specifically targeting excavator applications.
Okay.
And then, of course, a variety of new and creative cartridge valves that we're introducing. The upgrade to HF Impulse is kind of especially exciting. We introduced HF Impulse to the market as a bridge for hydraulic engineers at small to medium-sized companies to gain more confidence in configuring controllers and integrating those devices with more or less traditional proportional valve product line. And how we did that was by providing an easy to apply and configure library of common functions that they could configure. HF Impulse 2.0 expands on that and broadens the library of functions, makes it easier to store and use these functions across multiple controllers, but also allows these engineers who are more confident now, who have been doing some configuration programming, to actually program in C++, use standard text editor or diagram editor to create more customized program libraries. I would just say, anyone interested in seeing the latest in electroproportional technology for compact hydraulic control should come to the Hydroforce booth. Our booth is going to be pretty unique. It's going to be sort of separated into two sections. One that everyone's going to be able to see all the new products I mentioned, and then another section that we're calling our collaboration zone, where engineers and machine designers, they can come and see live demonstrations of HF Impulse 2.0, some updates to our iDesign, which is our hydraulic manifold circuit design tool. And the collaboration zone is really intended to be a unique opportunity, to discuss solutions for your machine's most difficult control system challenges. And our staff of highly trained and experienced application engineers will be there to consult with anyone face-to-face in a private meeting room or just relaxing on some comfortable sofas we'll have there.
Yeah, well, that sounds great, Russ. You're really embracing the spirit of the show. As we both know, we're co-located with ConExpo, ConAg, and so all of those machine builders that are exhibiting on that side of the show really take advantage of IFPE to come and see the latest advances. And it sounds like what you just described, get their hands on some of the latest advances for fluid power technology. So thank you and kudos to Hydroforce for spearheading that.
Well, thank you. Thank you very much.
Well, great. All right. Well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Russ Schneiderwind, who has been my guest on this episode. If you would like to connect with him, I know the best way to do that is to drop him an email, and we're going to put a link to that email address in the show notes for this episode. To learn more about fluid power, your best bet is to attend IFPE. Hopefully you're already doing that. The International Fluid Power Exposition, where you will see firsthand the latest fluid power technology advancements and learn from industry experts. And remember, if you like our podcast, follow us on Twitter. We're at the NFPA. And please keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from our listeners about the kind of topics you'd like to hear addressed on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.